Hello everyone, hope you are doing well. In today's video, we are gonna discuss the questions based on chapter 2, that is data representation. If we talk about the chapter data representation, there are three important topics. First is number system. The second is number conversion, in which we have to convert number from one number system to another. And the third topic is about different encoding systems. First of all, let's discuss the different type of number systems. On this topic, you may get 1 mark question. There are total 4 types of number system. The first is decimal number system. In this number system, the digits are from 0 to 9. So, the total number of digits are 10. That's why the base of this number system is 10. The second number system is binary number system. The digits present in this number system are 0 and 1. So, the base of this number system is 2. The third number system is octal number system. The digits are from 0 to 7. Total digits are 8. That's why the base is 8. And the last number system is hexadecimal number system. The base is 16, means we will be having total 16 digits. But where are 16 digits? The digits are only from 0 to 9. In this way we got 10 digits. But what about the remaining 6? For that we will be using alphabet A through F. In this range, A will represent 11, B will represent 12, C is used for 13, D will be 14, E will be 15 and F will represent 16. So that was hexadecimal number system. So if you get question based on number system, write the digits available in that number system and the base of it. The most important topic in this chapter will be number conversion. There are total 10 conversions which I have divided into 3 sets to make it easy. The first set in which you need to convert the number from decimal to other number system. So from decimal to binary, from decimal to octal and from decimal to hexadecimal. So whenever you see any question on number conversion, first you will figure out to which set it belongs. If you want to convert to binary, you will be repeatedly dividing the number by 2 and then you have to note down the remainder. Similarly, if you get conversion from decimal to octal, you will be doing repeated division by 8 and noting down the remainder. Follow the same process for the conversion from decimal to hexadecimal. Here we will be repeatedly dividing by the base of the hexadecimal number system, that is 16. Before discussing other type of conversions, let's check out the questions based on it. So here is the conversion in which you need to convert the number from decimal to binary. We understood that the conversion is from decimal to other number system, means it belongs to the set 1. This is the first category where we are converting the number from decimal to binary, in which we have to do the repeated division by 2 and note down the remainder. If you know the answer, I would suggest you to pause the video and try it yourself. Hope you got the answer. Let's check out. If you didn't get the answer, no problem. You can cross check with this answer. Let's start the process. Dividing number 84 by 2, we will be getting 42. Remainder is 0. In this way, we will be continuing the process. 42 divided by 2 will be 21. Remainder is again 0. Now let's divide 21 by 2. We will be getting 10 and the remainder is 1. Because it is not completely divisible by 2, we got remainder 1. Follow the process. 10 divided by 2 will be 5. Remainder is 0. In the next step, we are dividing 5 by 2. 2 2s are 4. Remainder is 1. Let's continue. Divide 2 by 2. It will go once. Remainder will be 0. I prefer to divide the number until we get 0. So 1 divided by 2. We cannot divide the smaller number by the bigger number. So I am dividing it by 0 times. Remainder is 1. We got all the remainder. It's time to note down. That we will be note down from bottom to top. So it will be 1, 0, 1, 0, 1, 0, 0. So in this way we got the answer. Hope you understood this explanation. If you want to practice one more question of this category, here it is. Let me know the answer in the comments. Okay guys, now it's time to move to the second category of the conversion from the set 1. The conversion is from decimal to octal. For octal number system, the base is 10, so we will be repeatedly dividing by 8. If you want to try it yourself, pause the video and give it a try. I hope you got the answer. Let's check out. Here I have used the same number 84. So let's divide 84 by 8. 8 tens are 80. Remainder will be 4. Continue the process. 10 divided by 8. 8 ones are 8. Remainder is 2. We will follow the same concept. Divide the number until we get 0. We cannot divide 1 by 8. So it is 0 times. The remainder is 1. Let's note down the remainder from bottom to top. Finally, we got the answer. What do you think? This is simple or hard? You need to be little careful with the calculations. One question arises in my mind. Can we cross-check this answer whether we got it correct or not? Don't worry. Anyhow, we are going to study the reverse conversion in the second set. Then you can easily cross-check this question with that process. If you want to practice one more question, here it is. In case of any doubt, you can drop a comment. Moving ahead to the third category from this set, where we are converting the number from decimal to hexadecimal. The concept will be same. We are going to divide repeatedly by 16. As I mentioned, same number I am going to convert in other number system from decimal. Let's check out the answer. We need to divide 84 by 16. 16 5s are 80. Remainder is 4. Let's divide 5 by 16. That we cannot divide. We are dividing it by 0 times. Remainder is 5. Note down the remainder from bottom to top. So here is the answer. For your practice, here is one question. Give it a try. In this way, we completed set 1, in which we covered 3 types of conversions. From decimal to binary, from decimal to octal, and from decimal to hexadecimal number system. The base of binary is 2, so we will be repeatedly dividing by 2 and noting down the remainder. The base of octal is 8, so we are repeatedly dividing by 8. Similarly, the base of hexadecimal number system is 16, so we are repeatedly dividing by 16. Hey, it's time to move ahead to the second set. In this set also, we are going to cover 3 types of conversions. Which are they? From other number system to decimal. That's why we call this set as 2 decimal set. From binary to decimal, from octal to decimal, and from hexadecimal to decimal. Now what procedure we will be following? In this, the given digit will get multiplied to its positional value. If it is a binary number system, the positional value will be calculated as a power of 2. It is also called as weight. We take the power from right to left. In this way, we will keep on proceeding and keep on multiplying the digit with its positional value. Finally, we take sum of it. So ultimately, we are calculating the sum or product of each digit with its positional value. If it is a binary number, we take power of 2. If it is a octal number, we take power of 8. And if it is a hexadecimal number system, we take power of 16. Don't worry if you didn't understand the explanation, we will do it with example. So let's try to solve the first conversion from the set 2. If you remember, this is just the reverse process of the conversion what we have studied in the set number 1. There we converted the decimal number to binary. Now we are converting binary to decimal. Now you will know how to cross check your previous answers. Even if you remember, this was the answer when we converted the number from decimal to binary. No worries, we will try this conversion binary to decimal. Alright, now let's follow the process. If you know the answer, you can do it yourself. Start solving from right to left. The first number is 0. The positional value for this first digit will be 2 to the power 0. The second number is 0 and its positional value is 2 to the power 1. Proceed in the same way. Third number is 1. The positional value is 2 to the power 2. The next number is 0. Positional value is 2 to the power 3. After 0 on the right hand side we have 1. Positional value is 2 to the power 4. Then we have 0 and the positional value is 2 to the power 5. In the same way we will be proceeding. In the next step we will be simplifying it. We know that any number multiplied by 0 will be 0. So no need to simplify the term where we have multiplication with the 0. Finally we have only 3 terms to solve. 1 into 2 to the power 2, 1 into 2 to the power 4, 1 into 2 to the power 6. 2 to the power 2 is 4, 4 into 1 will be 4. 2 to the power 4 means 16 and 2 to the power 6 means 24. If you cannot calculate directly, write the number of 2's accordingly and multiply it. We got 64 plus 16 plus 4. 16 plus 4 will be 20. 64 plus 20 will be 84. Now you can recall this example. We took the same number and converted it to binary in the first set. That was our first example. Look at this first example. If you want to cross check, you can follow the same process. Write this number, take the positional value and multiply it. Here 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5 and then finally we will be getting 2 to the power 6. Don't calculate the numbers which are multiplied with 0. 2 to the power 6 is 64. Then we have 16 plus 4. Ultimately we got 84. In this way you can cross check your answer. Some more exercise for the brain. Here is one question. Try to figure out the answer. Wow, this session is getting interesting. What do you think? It's time to move ahead to the second conversion from this set, that is 2 decimal set. Here we are gonna convert octal number to decimal number. The base of octal number system is 8, so the positional value will be power of 8. I would suggest the same. If you know how to solve it, go ahead. Alright, it's time to follow the process. Starting from right, the first digit is 4. So the positional value will be 8 to the power 0. The second digit is 2. The positional value is 8 to the power 1. Finally, we have digit 1. The positional value is 8 to the power 2. We have studied in maths that any number has power 0 will be 1. That's why 8 to the power 0 will be 1. 8 to the power 8 will be 8. 8 to the power 2 means 8 square will be 64. So 1 into 64 will be 64. Then 8 2s are 16. 4 into 1 will be 4. Okay, let's simplify. 16 plus 4 will be 20. 64 plus 20 will be 84. This is also the same example which we have considered in the from decimal set. Let's go and check it out. Here we are in the set 1, that is from decimal set. Wow, it's so simple to cross check the answer because you know the reverse process of it. Take the number, multiply each digit with the positional value and then take sum of it. 64 plus 16 plus 4 will be 84. In this way you cross check your answer. Hope you are getting my explanation. Let's check out the third conversion from the second set. Hexadecimal to decimal. The base of hexadecimal number system is 16, so we will be taking power of 16. Let's follow the procedure and calculate the answer. From right to left, the first digit is 4 and the positional value is 16 to the power 0. The next digit is 5 and the positional value will be 16 to the power 1. Any number having power 0 will be 1. 16 5s are 80. 4 into 1 will be 4. So 80 plus 4 will be 64. Here is one more question for practice. Try it out. I am again taking you back to the first set, because you should have a clear idea how to cross check your answer in case of doubt. Just now we studied the reverse of it. Take the number and with the positional value multiply it. 16 5s are 80 and 4 into 1 will be 4. So we got 84. In this way we got the same number. It means our answer is correct. Hey guys, with the two sets we sorted out our 6 conversions. Hope you are also getting the concept what I am trying to explain you. I am really feeling happy that I could sort these conversions for you. What is your view? Please let me know in the comments. Now moving ahead to the remaining 4 conversions that I have kept in set 3. Which are they? In the first category we have conversion from octal to binary and the reverse of it, binary to octal. In this set there is one more category in which we will be converting the number from binary to hexadecimal and the reverse of it is hexadecimal to binary. We will be doing this with direct conversion. What does it mean? Let's understand with example. From the first category, let's solve one question in which we need to convert from octal to binary. Let's figure out it. Write the individual digits 4763. Okay, we took the digits. Now we need to convert it to binary. That too we are doing with direct conversion. Direct conversion means you should know the binary equivalent of 4, but I don't know how to calculate it. That time you should be considering this table. Before converting octal number to binary, one thing we should keep in mind that for octal numbers, 3 bits binary digit is sufficient. Why? Because in octal number system, the digits are from 0 to 7. So 3 bits binary number is sufficient to represent these digits. Now let's understand how to figure out the binary equivalent. As we are gonna calculate the binary equivalent, we will be taking the positional value of binary number system. So 2 to the power 0, 2 to the power 1 and 2 to the power 2. Only 3 bits. 2 to the power 0 will be 1, 2 to the power 1 will be 2 and 2 to the power 2 will be 4. Now I want to represent 0 in the binary. I don't want 4, I don't want 2 and I don't want 1 also. So all will be 0. Now proceed to 1. To make 1, I should be writing 1 in the column 1. And other bits will be 0. So in this way I will be getting 1. Now for the conversion of 2, look at the column where you are getting 2. I am getting 2 in the second column. So write 1 bit there, the remaining bits will be 0. In the same way we will be writing the binary equivalent for the other digits. To make 3, I should have column 2 and column 1. So write bits 1 here, remaining will be 0. To make 4, I will be writing 1 in the 4 column and other bits will be 0. To make 5, I should be writing 1 in the column 4 and 1. So I will get 5. To make 6, what we need? 4 plus 2. So here also 1, here also 1 and the other column is 0. To make 7, I should add 4, 2 and 1. So I am writing 1 in all the columns. In this way we calculate the binary equivalent. After making this table, directly we will be placing the binary equivalent for the digit. 4 is 100, 7 is 111, 6 is 110. And what's the binary equivalent of 3? It is 011. After placing down all the values, write the final answer. If you understood this table, reverse process will be very easy. Let's do it with example, binary to octal. Here is the process. First of all, we will be grouping these digits in 3 bits. We will be getting this type of groups. This is first group of 3 bits, then second group, then third group, then fourth group. In case if you will not have sufficient bits to group it, you can add that many zeros at the left hand side. In this example, we have correct number of digits, so we could group it into 3 bits. Now you will be directly placing the octal equivalent of the binary number. 100 is 4, 111 is 7, 110 is 6 and 011 is 3. So we got this number. It is nothing but the reverse process of the previous conversion. To solve these questions, please make this table so that it will be easy for you to write the answer. Hope you understood the first category of conversion from the set 3. Alright, after doing lot of calculations, now we are at the last category from the set 3. Here we will be converting number from binary to hexadecimal, and the reverse of it is hexadecimal to binary, that too by direct conversion. Let's understand how to do it with one example. Pause the video if you know how to do it. Okay, let's try to understand the process. Here is the given binary number which we have to convert to hexadecimal. We understood one thing from the previous category of conversion, that for octal number system 3 bits are sufficient to convert from octal to binary and from binary to octal. But for hexadecimal number system 3 bits are not sufficient. We need 4 bits. Because in case of octal number system, the digits 0 to 7 can be changed into binary with 3 bits. But in case of hexadecimal number system, we have 0 to 9 digits and then A through F, which represent the digits 10 to 15. So for that fourth bit, we will be taking the positional value 2 to the power 3, means 8. We know how to convert the digits from 0 to 7 to binary. You need to just add one more 0 to the left side to make it 4 bits. Now let's see how to convert the digit 8 to binary. The digit 8 we can see we are getting at this column. So place 1 at that column, the remaining bits will be 0. Now what about digit 9? 9 we will be getting by adding 8 and 1. So place 1 bit on that column and the remaining column will be 0. In hexadecimal number system, after 9 we have alphabet A, which represent 10. How you will be getting 10? 8 plus 2. So place 1 in that column, remaining will be 0. Following this procedure, you will be getting the binary numbers for the remaining digits. 11 means you have to place 1 in the column 8, 2 and 1. What about 12? 12 will be 8 plus 4. So place 1 in that column. 13 will be 8 plus 4 plus 1. 14 will be 8 plus 4, 12. 12 plus 2 will be 14. 15 means all the columns. Now let's convert this binary number to hexadecimal. Make group of 4 bits starting from right. So this is the first group, this is second group and this is third group. If you don't have sufficient bits to make a group of 4, add required number of zeros on the left hand side. Now look at this number 1100. It's C. This is a binary equivalent for B and here we got 7. So final answer will be 7BC. Oh wow, we are at the last exercise to the brain, the reverse process, hexadecimal to binary. Look at this example, it's same. Now I trust you can solve this very easily. Alright, let's follow the process. These are the digits 7BC. And here is the binary equivalent of C, binary equivalent of B and 7. In this way we will be getting this final answer. Make sure that you are not making any mistake in preparing this table. With that we have studied all 10 types of conversions. Now I am pretty sure that you don't have any doubt that which process to follow for conversions. Whenever you will look at the question of number conversion, recall this screen. First of all, try to fit that question in one of the set, whether it is from decimal to decimal or these 4 types of conversions. Then it will be easy to solve it. After solving these questions of conversion in the exam, let me know whether it was helpful for you or not. Let's quickly go through the third topic, that is encoding system. You may get question where you need to expand these terms. The first one is ASCII or ASCII. It is an American standard code for information interchange. And the second one is ISCII. It is an Indian standard because it supports Indian language. So, Indian standard code for information interchange. The third encoding system is Unicode, where you have 3 types: UTF-8, UTF-16 and UTF-32. Hey guys, that's all for today's video. If you find this helpful, do share with your friends. And if you are new here, subscribe to the channel to get updated. In the next video, we will be going through the important questions from the chapter number 3, that is Boolean logic. So until next time, stay curious, stay healthy. I will see you in the next video.